The analysis of variance is a statistical technique for comparing the means of multiple groups or populations. It's useful for figuring out which groups are significantly different from one another and for testing the null hypothesis that all groups have equal means. ANOVA can be used in a Lean Six Sigma project to analyze the relationship between independent process variables and the project's output. ANOVA can be used to compare the mean product quality of different production shifts, suppliers, or product batches to see which one is significantly different from the others and thus may benefit from improvement. In Lean Six Sigma Process Improvement Project, a critical review of ANOVA would consider its strengths and limitations. On the plus side, analysis of variance is an effective tool for comparing means and can reveal helpful insights into areas for process improvement. However, it has restrictions, such as requiring an excessively large sample size to guarantee the validity of the results and assuming that all variances are equal. In order to better understand how ANOVA can be applied to Lean Six Sigma project, it is important to conduct a literature review. The best ways to choose which groups to include, how to deal with incomplete or missing data, and how to analyze the results would all be investigated. ANOVA can be used by a product manager to compare the mean customer satisfaction of different product lines or market segments. A product's category or market niche could be used as an independent variable, with customer satisfaction serving as a lone-dependent variable. Product managers can use this comparison to make data-driven decisions based on what their customers want and improve customer satisfaction by focusing on the product lines or market segments that need the most work. Example, let's say a manufacturing firm is keen on enhancing the quality of its products. They need to establish which of the 4 suppliers has the highest mean quality, therefore they compile data on product quality. In this case, the supplier is the independent variable, and the quality of the product is the dependent variable. The company can use analysis of variance to evaluate the average quality of items from each supplier and see if there is a statistically significant difference. Here's the hypothesis that may be put to the test. According to H0, the mean of product quality across all 4 vendors is equal. The means of product quality from at least one supplier differ. The analysis of variance test will be carried out. If the results are statistically significant, then the company can conclude that one of its suppliers is significantly different from the others, rejecting the null hypothesis. When a supplier's performance is identified as needing improvement, the organization can direct its attention there and make data-driven decisions to boost product quality.